Hello, everyone. Are you all able to see with no distractions?
Looks good to me.
Yeah.
Is there anything in the way of the screen? Just the title page, correct?
I can see.
Yeah.
Okay, perfect. Thank you so much. Okay. Have you ever experienced the hassle of getting residual product or food on your hands, which makes you not want to touch your tech device while cooking? If you have, our team today would like to offer you a solution to resolve this situation. Cutlery is a mobile application you don't want to miss out on in your kitchen. By utilizing eye gaze technology and the freedom of your own device, we bring you a hands-free experience, and most importantly, Cutlery is free. This product is brought to you by our team, Ni Nguyen as our project manager, Leila Mansour myself as Scrum Master, Christopher Delgado as Senior Backend Developer, Benjamin Carmeli as Quality Assurance, and Matthew Kim as Developer. Now I'll be showcasing our product. We'd love to receive feedback from you from this demonstration with the intent of making it even better. We will walk through 4 main parts. First, we'll start off by discussing our product concept, then our demo video, followed by our market analysis, and finishing it off with our future plans. First up, the product concept. As mentioned, Cutlery is a cooking recipe mobile application that is integrated with eye tracking algorithms. It allows the choice of interacting with your mobile device by either touch or with your eyes. We were motivated to design a more convenient way for clients to access our technology. Our design for the project consists of an eye tracking feature, our key mechanic. Eye reflections are picked up through the camera sensor and converted into eye movements, and finally cursor movements on the recipe layered interface. The project has been targeted towards iOS users that own a device no earlier than iPhone X models. Our project was implemented on Unity 2020 and incorporated with AR Foundation 4.0 framework, which supports many features for face and body tracking. Shader lab files consisted of fixed function settings which tell Unity how to render for the front end. By picking mobile devices compatibility, we made sure the user will not require any extra sensor device such as a wearable product. The camera, the most important part of the system, will act as the input. In order to make the application functional, the camera in use is not to include an infrared filter so that it can illuminate the eye with an infrared source. Most workable eye tracking programs out there are currently for iPhone X or newer versions. We will try to make a program compatible with older versions as well. Our goals consisted of implementing eye tracking technology to enhance convenience and efficiency for daily use in the kitchen. We wanted to challenge ourselves to something unfamiliar because we were eager to learn. All of our team members are curious about these type of technologies. We believe it will be widely applied in the future as human-computer interaction becomes the norm and activities with the eyes are natural and do not require much training compared to using a mouse or a keyboard as an input. Eyes can be more precise towards the focus area or the area that actions will take place. For a better understanding on our product's mechanics, let's together watch this demonstration from our developer, Christopher.
So here you can see the calibration page. Here, AR Foundation handles the tracking of the eye rotations. We use the rotation values to help determine how much space within the screen we should move for every rotational value. That math is done within the movement script, which converts the rotational values to float values, which tell us how many pixels we should move per rotational value. Here you can see the clicking. This is happening because we're staring at a certain button for a certain amount of time. So currently, this is being handled by the staring to clicking script. The script is attached to the cursor game object along with a box collider, which is used as a trigger. We then apply box colliders to the buttons, and these will actually exist to help us detect the buttons. So if the box collider attached to the cursor detects one, it'll first check if the parent containing that collider is actually a button. And if it is, it starts a countdown from 2 seconds, and then it'll call the button's click method. If the cursor happens to leave that collider, so that button, and enters a new one, appropriate steps are taken to make sure that we don't click the previous one, but we click the new one. And the timer will be reset so that you're not passing through multiple buttons and then clicking the last one on the way out. And then here we have a demonstration of the recenter feature so that you can go ahead and do whatever you need to do within the app, leave, and then come back, recenter your face, and then you can keep on working.
All right, here is a simple user manual on how to use our application. When a user opens the app, it will ask the user to position themselves so the eye tracking system can calibrate. Calibration is done by having the user fixate on set points on the screen. This will start as the camera is turned on. The user will need to ensure the device remains still to let the picture be focused. Once this is complete, the user's eye excuse me, and the app will present the main page. When a user wants to access a button on the app, they will simply stare at it for a certain time to activate. Within Cutlery, calibration is a smooth and easy process. The user will be able to browse recipes by food cuisine and by ingredient. Favorite recipes can be bookmarked. A description, required ingredients, and instructions are all provided for the user. In the picture above, we see the tracking process. The user needs to be located within the tracker's track box. The tracker here is the camera on top, which is enabled by the eye sensor embedded inside the device the user is operating. The eye sensor contains a camera that captures the action of the eye before processing the action captured, allowing the camera to track the reflection of the light source along with the pupil. Then on the right, we also have an example of data storage and user data storage, which we'll go over a bit later. So here are the stakeholder requests, which consisted of save user eye gaze heat map, which gives users easy and quick access to the application's actual purpose. Save user configurations and settings, which is a convenience to allow users to store previously entered data. An example of the heat map is shown on the top left, where an image is viewed by users. Each user views the picture for 10 seconds. The data is recorded for each image, and we focus on the data with the longest duration of time. This data was picked from various age groups. And here we have a more detailed overview of our data. On the top left, we have the user info extracted from the database. The top middle shows an attention map where each user stared most. The top right is data from the 21 years age group. Bottom left is total age for each image. Bottom middle is the duration of each age group. And bottom right is the total duration for each image. So now we have our database design. Our database server duo, PHP and MySQL, was used to enhance the user experience. For our database, Unity and MySQL are working directly together. The local machine is used to create the server via XAMPP with Apache, PHP, MyAdmin, and MySQL. Our heatmap goes forth with the data from the database. So PHP takes the website URL form to send back the results. The data can then be used on the page website as we wanted to, and it's a process of receiving and embedding the translated data. MySQL is the actual data itself where the information is stored. It's a table of data, and this will prove useful when we wish to retain information from the user. In regard to Cutlery, as we have presented the database prior, the MySQL database requires security and protection. The user's login and configurations will be stored and accessible for later use. With the server duo of PHP and MySQL, the data, MySQL, can be retrieved from PHP web front site, then stored into the database. To ensure this can be done safely, we had to implement proper measures for user confidentiality. We implemented a hash system, which obtains the password entered by user, converts it into hexadecimal, and encrypts the information. If a match for the username entered is detected, it cannot be used as there is an existing user. Next, we have market and competition analysis. According to our research, we have found there to be fierce competitors in our industry. We are one of the few implementers of a scroll, swipe, and select through eye control. The big guys like Toby, Microsoft, and private researchers are very well equipped in features and algorithm design. We chose a recipe app as we felt it was a unique idea and provides a beneficial purpose for the eye gaze concept. Cutlery has free access, whereas other systems are expensive. Some range from $500 or more per system. Cutlery is developed for mobile users, whereas only few applications are available for mobiles currently. Our app is easy to set up and has quick calibration. Other apps are available, but for experimental use and not real-world conditions and require a complicated setup. Example is Toby. Our product is intended for daily use. It's innovative and is built with special need users in mind, which makes us stand out. What have we learned from this process? As of now, Cutlery is compatible with iOS devices available on the Apple App Store for iPhones and iPads. We'll expand our platform to Android devices and eventually PCs with built-in cameras and eye tracking capabilities once development is complete. Currently, we are waiting for approval from shareholders and the final rundown of our app. We enjoyed working in Unity as it was a new experience for all our team members. We adapted to the platform and implemented C#, which required learning how to use textures and GUI construction, which proved more difficult than we expected. Bugs were complex to detect and solved as there were dependencies. We put the Agile methodology into practice with Monday.com used as our team management system. And we found that study shows eyes have great potential in terms of technology. We would like to build into this innovative tunnel with our app. Thank you, guys.
Alrighty. So if there are any questions for our speakers, go ahead and issue them now. And if as a regular audience member, if you did have a question, feel free to throw it in the chat as well.
In your database, how many users enter data in the system? I mean, how many examples of use did you use for that database?
Yep. So for our heat map example that I showed prior, in one of them, the 21 years age group had about 100 users. So we also tested it out with our friends and family because you sometimes get the best data from those who are close to and who can actually use your app on a daily basis. So we tried to get their opinions as well to see where we could improve or adjust our app.
Okay, thanks.
Mm-hmm.
So did you include recipes from recipe books, or are people inputting their own recipes to use with the system?
Yes, so we try to scourge around and find recipes. A lot of the recipes we have right now are according to ingredients. So it's like chicken, beef, or pork, and different recipes correlate with that. And cuisines as well, like Chinese and Asian, various Asian dishes.
So are these all recipes you guys provide, or are there ways for users to input their own recipes?
Oh, I'm sorry. Yes, we provide those, and then the user can just search them by ingredient or by name.
Okay.
So for the hot spots and things like that on the recipes, did you guys mark that up then using some kind of markup language or?
I'm sorry, what was that?
Well, for the recipes, you had to define those boxes, those bounding boxes and the collision areas. So you define those all ahead of time?
Yes, correct.
That was just configuration files or some graphical utility to do that?
Yes, it was configuration files.
And then one question just about the camera. I'm sorry, it's not really a CS question, but the you said it needed to not have an IR filter, but an iPhone typically has one in there. How did you deal with that?
Yeah, so for the infrared, it's just so your camera needs to be propped up and no external light showing so that your face can clearly be detected. And let's say that you leave the screen and come back, it can right away recognize, oh, this person has returned. So in terms of the red light, just like not a bright, stark red light showing into the screen is sufficient, which an iPhone would suffice.
So are glasses an issue? People who wear glasses?
Yes, so we would like to make our product glass wearable. It's currently not. It is for iPhones and tablets. But yes, that is a future goal. We're really trying to get into, like the Google Glass and everything, research into that.
I'll go ahead and throw in a question of my own, just kind of a very general one.
Sure.
If you had to start this project all over again from the beginning, but knowing what you know now, is there anything that you would approach differently this time?
Sure. So me and my team members, we had discussed this. In the beginning, we did find some difficulties finding compatibility with our program Unity. Every single member on the team was new to Unity, so it was a very high learning curve. So we did find that we had to upload textures for Unity and make a whole GUI construction, which I mentioned before as well. it took a lot of time because you had to find very minor defects and bugs, which it would take hours and hours. So we would maybe use a different language, perhaps. That's what we thought about, like maybe something that allowed us more openness, like C++ has SFML library and all that stuff. So yeah, that would be one takeaway.
Okay, thank you.
Mhm.
Are there any other questions from the audience? We have time for maybe one more, or anybody for that matter. We have time for probably about one more question. I'll throw one in there if there are any. Oh, sorry, was that a question? Oh, you're muted. Sorry.
Sorry, I lost focus. I was using the space bar, but I was on another app. So one of the questions was all the data collection is really more about seeing what the behavior was and things like that, because presumably once you have defined the hotspots and the system's working, then that's all sort of standalone and you wouldn't need the data collection?
Correct.
Right?
So for the database collection, what we did want to have is the user configuration. So let's say if a user has bookmarked a recipe, or they are in the process of a recipe, and let's say their app closes down, when they open it, it recalibrates and gives them the recipe right away, or a login or something of that sort. Mhm.
Makes sense. Yeah.
Thank you.
Alrighty. That's it for the Q&A. Thanks everybody for thank you for your presentation, and thank you judges and for your questions.